Okay, Aryan, Mike, and Noah. My laptop crashed just now. Yeah, that's why I was out. Can you hear me now?
Yeah.
Okay, Aryan, I lost the previous page. Yeah, would you please first landscape and then show me the previous page I was trying to copy? Yeah. 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 Using- Okay, so Aryan, we're using the previously the 10th April Jamboard. Yeah, there isn't anything in, so we're just using it again. I renamed it already. I'm gonna copy it there. Yeah. Yeah. Sorry, people. My laptop crashed just now, so it's a bit of a delay here. All right. Okay. Okay. I got the copy. Ainesh, would you please show me the next page? Michael, any homework to ask today?
Yeah.
All right, then let's do the homework first. Shift to the left, Aryan, and then we'll do the camp later. Okay? Aryan, shift to the left a bit. I cannot see the page fully. Thank you. All right, okay. Noah, any homework to ask today?
No.
All right, then let's prepare for mid-year. No, if please do something. Please do something else first. While then I'll send you the practice questions. Yeah, Noah. Yeah. Okay, so Aryan, what is your question for this one?
I'm not sure what's the independent variable and the dependent variable.
Right. So sorry. Okay, so what is it that you're measuring in this experiment? That's one of the best way to find out. So what is it that you're measuring?
I'm trying to find the relationship between the.
You must be changing or measuring something and then measuring something else also. What is it?
Changing the image distance.
The which distance, sorry?
Image distance.
Image distance, and the image distance is probably what? The screen can move also, is it?
Yeah.
Right. So the U is changing. Let me just confirm that the U is changing. The object is
changing.
The U is not changing. Sorry.
Yeah.
Oh, then okay. Then the V is something that you change. Wait, what? No. If the U is not changing, the V will not be changing, right? Sorry, I don't get that part. What is it that you are changing in this experiment?
I'm changing the V.
You're changing the image distance. Okay, now if the object distance doesn't change, how can the image distance change? Sorry. Are you saying that you move the lens? You move the lens, is that what you're saying?
I move the screen.
You move the screen. So the lens is there, the object, the U doesn't change, but the what? So you record the image distance once, is it? Once.
Yeah.
If
no,
that's
I record the object distance once.
You record the object, the U once, the U, yeah? Okay, the U once. Then the V, you record how many times? Because V is, if the U is fixed, the V will be at that particular direction. We just get once, right? Maybe you measure 2 or 3 times, but it's there only, right?
Oh, does this mean that both the U and V have to change?
Well, if I put it another way, if the U does not change, the V does not change one. The U is there, therefore the V is there. In the sense that the image will be there if you never change the U. That's why I keep asking, what is it that you're varying in this experiment? Sorry, did you do the experiment, or is this like just a practice paper?
I did the experiment.
Then in any experiment, certain things will vary, right? That's the
Yeah.
first thing. So what do you vary? It cannot be the image distance. The image will, if the image is blurred, that's not the image distance one.
Yeah.
Is that all that you vary in the experiment? The screen distance? That's all.
And
What else do you vary in this experiment?
I mean, I also vary the U
By doing what, if I may confirm?
by just like increasing by 0.5 meters or decreasing.
So your lens move lah, basically lah.
Yeah.
So your lens first move, and then you go find the image lah, right? Okay, clear, yeah? Correct, yeah? So your U actually move lah. Am I correct or not? The U actually move. If U is called the object distance, then U must have moved.
Oh, so the U is the independent variable.
Correct. And the dependent variable is the V. Correct. The plot will be 1 over U with 1 over V lah. So slightly different lah. But the variable clearly U and V. Clearly lah. Make sense? Based on the experiment, makes sense or not?
Yeah, then what's the control?
Can I read where they ask you for control? Sorry. Where did they ask you for control? Sorry.
No, I mean we need to give the control variable.
The control variable, is it control?
Yeah.
Wait, what's the difference between control variable and independent variable? Sorry, yeah. Let me think about it and answer. Sorry, I don't get that difference. Yeah.
Control variable is like it has to remain constant at all times for the experiment to work.
The focus of the lens?
Yeah.
No, not necessarily. Not necessarily. There's a lot of control variable if you put it that way, like the lens does not change, right? The lens does not change. Therefore, the focus of the lens does not change. The size of the object, that's no way. I don't get. There's a lot of things that are left constant in this experiment. Yeah, right. The object itself does not change. The lens does not change. That's already two things. The height of the lens does not change. Did they ask you just for one control variable, or did they ask for quite a lot?
Just one.
I would say the lens does not change. Meaning, for example, in this case, therefore, the focus of the lens does not change. I would probably answer that. I'm sorry, I'm not too sure about that one, but that's what I will try. Right? Because obviously the lens itself does not change, only the distance. Okay.
Yeah.
All right. So give it a try. So Noah, you're doing something else. All right. So Mike, what is your question currently?
Number 6.
All right, let me copy first, yeah? Is that you're working on the left? Sorry, a bit small.
No, that's
Right.
question 4.
Oh, okay, let me copy question 6 first. Easier that way. Okay, then if you have a working, show me your working, yeah? Mike at yesterday's Jamboard, yeah? Page 12, right? So Mike, if you have a working, is that question 6 you're showing? Oh, you're just starting, is it question 6?
Yeah.
All right. So what is your problem with question 6? Again, what is your problem with question 6?
I think it's the fact that it's a square.
Now, think about this carefully. This is why I asked you in holiday tuition. As in integration, can you handle such a square? This thing.
Yeah, but I forgot how to properly do it.
No, you cannot. Why? Because there is no
cannot.
rule. in integration. So if this is differentiation, this is not differentiation.
Oh,
If this is differentiation, can you handle such a square?
yeah.
Because you have a certain rule.
So
What rule will you apply? What you apply in the differentiation? What rule?
I don't know what it's called. It's a power rule.
Chain rule. Yeah, okay. The power rule, which is the chain rule. Now, you don't have chain rule in integration. You have no rule in integration. The power square is not just a big problem, it is an insurmountable problem. It is impossible. That means you have to do something else to it.
Okay.
Understand first? And that's the issue. So since you cannot attack the problem directly, you have to modify it a bit. Any idea what I'm talking about here?
Modify it.
Okay, I'm going to show you again. I'm going to show how I purposely modify properly, because it is impossible to do at its current state. So watch.
Okay. What do you expand it?
Well, I will expand it. And does that solve our problem? That's the question, right? So if I expand it, now you look at this situation now. I'm supposed to now integrate these three things, right?
Yeah.
Okay. Can I integrate these three things? Well, I can solve it one by one because minus and plus, right? So can I integrate this guy?
Which guy? Sine square x.
Yeah.
No.
No, because again, the quad is a problem. Oh my goodness. Okay, it's not solving a lot of problem. Can I solve this guy? Can I integrate this guy?
Yeah.
Oh no, you can't, because times is a problem. You don't have product rule. It's a problem. It's really a problem, right? Can you solve cosine square x?
No.
The square is a problem. So is expanding helping us or not?
No.
It does. It does. Watch. Again, you should notice that it is still impossible. However, I'm giving you a lot of hints here. I'm giving you a lot of. However, with the help of the magic of identities, you can make them possible. I'm giving you a lot of hints here. What is this?
Sine square x cosine square x.
Identities. Come on.
Yeah. I need to find.
Yeah, you find the list, right? You don't have to memorize.
Equals to 1.
Okay, can you integrate 1?
Yeah.
Okay, and then this guy also. Come on, I'm giving you a lot of hints here.
Sine x cosine x.
In fact, 2 sine x cosine x. In fact.
So.
Come on. Come on.
Sine x cosine x.
Identities, come on. 2 sine x cosine
sine a plus b
equals to?
So sine a cosine b is equal to 2 sine a cosine b is equal to sine a plus b plus.
No, 2 sine a cosine a. 2 sine a cosine a. 2 sine a cosine a. 2 sine a cosine a can become from right to left. Stop reading from left to right only. From right to left, please, in the list. Oh, come on. Show me the list. Show me the list. Show me the list. Show me the list. If you can. If not, send me a soft copy quickly. Put it in the Jamboard. Yeah, put it in Jamboard. The way you read the identity is probably not good enough for exam. Yeah, probably not. We have to use it better. Okay, so put it in the Jamboard. Okay, let me show you how to read.
I don't have a physical thing.
Sorry?
I don't have like a physical.
Yeah, soft copy, right? Put it in the Jamboard, please.
Yeah.
Right, put it in the Jamboard, same page. Come on.
But okay, we know.
Aryan, are you okay so far?
Yeah.
All right. Noah, are you okay so far?
Yeah.
All right. Mike, what is taking so long to send the identities? Do you have them?
Yeah.
All right. Either send me or put it in the chamber. Come on. Have it? Sorry, Michael, do you have it? If not, okay, very excellent, very good. Okay, I'm gonna make it bigger, yeah. Okay, this looks a bit too much, right? This is not what they give you in exam, yeah, right? So I was hoping that you can give the ones they give you in exam, but this one's fine, right? So yeah, I think this actually confuses you because you don't even see this one. That one I objected that you don't see this one. Why am I highlighting that one?
Sine 2x.
Yeah, sine 2x, or in this you can sine 2x. Now again, the same question. Is doing that making the integration possible?
Yeah.
All right, then give it a try. Give it a try. In fact, the integration will be very easy, right? So give it a try and see whether, well, it's according to the answer key. Okay, Aryan, are you okay so far?
I'm not sure of this question.
All right. Let me answer that. Michael, you are not supposed to look at the answer key because the answer is given by the question itself, isn't it?
Yeah.
Right. So can you integrate and find this thing?
Yeah. I already found it.
Sure. Cool.
Yeah.
Right. Okay. So Aryan, which part are you not sure? Sorry. The
2D.
ensure. Oh, the ensure. Okay. So you remember your experiment again, Aryan, because you did it. Okay. If I'm not mistaken, you will have a slight problem, or rather a slight uncertainty, in deciding, for example, when the image is the most sharp.
Oh.
You have to agak-agak a bit. Am I correct? Like maybe it's here or maybe you shift a bit. You can't really tell you're using your eyes, but it's around there, the sharpness. That's one thing, right?
Yeah.
So there is a slight sharpness because you're using your eyes to judge. And how do you correct that? If you're a teacher or you think about one way to minimize that problem, that's what you write. If you don't, then we'll talk about it. Right? Okay. Also, the lens and the illuminated object is everything, 90 degree, nice standing. The screen also nice standing. If it is not 90 degree, it kind of it kind of distort the image lah. I'm not sure whether you face that problem in the experiment also.
Oh yeah.
Right. So if you face those problems, those are the things that you want to minimize, and that's how you describe how you ensure the accuracy lah. So how do I settle this problem? How do I settle that problem? Can you give it a try?
Yeah.
All right. Michael, any other questions so far?
So at the question 16, right? So
Sure, question 6, yes.
it says show that sine x minus cosine x square,
Yeah.
the integration of that is equal to x
Yeah.
minus sine square x
Yeah.
plus c.
Yeah.
I didn't get minus sine square x. No?
Tell me what is the integration of this guy lah, right? So obviously the integration of 1 is x already, right? So that's the one's done lah. That's the easy part lah. Then what's the integration of minus sine 2x?
Of minus sine 2x, isn't it like cosine 2x over 2?
All right, let's do that, right? Cosine 2x over 2, right? Minus lah, with a minus, right? Sorry, I just a minute. I'm checking everything. Yeah, everything seems to be okay. Yeah, okay. So minus half cosine 2x, right? All right. So that would be it lah. That would be it, right? And then plus 0. Now, again, I'm referring you to identities. I'm referring you to identities. Which one? Sorry, you're saying?
Is it minus cosine 2x over 2?
Sorry, because I didn't hear you say minus or not minus, as in, then I just write minus lah. So is it minus or is it plus, for example, in this case?
I put plus.
Excellent, excellent. I believe you are correct by putting plus because minus lah, right? So I guess so far so good lah. So I guess so far so good. Now I will direct your attention to the identities again. There's a lot of magic done with the identities. Now, which one should you be looking at? Probably.
The one with sine square x.
No, that's the answer key. You cannot. Well, I suppose you can. Which one contains sine square x then?
One at the bottom.
Which one? Which one? Which one are you looking at?
Double angle formula.
And which one of the double angle formula?
Middle one.
The which one? Which one? Sorry, which one?
The middle one.
Okay, again, like use your mouse to indicate who are you looking at, right? So you're looking at basically this and that. Just to be clear, this and that lah, right? So, well, I mean, is that helping you?
Yeah.
And give it a try. Let me see what you do, and I believe you're on the right track. I believe. Give it a try, yeah? Give it a try. Noah, any questions so far?
Yeah.
All right, please show me your question. Yeah?
12.
12. All right, I'll zoom in just a bit, please. Sorry, zoom out a bit. Yeah, kena cut already. Kena cut. Just zoom out a bit. Zoom out a bit. Kena cut already. Okay, thank you, Noah. Show me your working. I'm using the yesterday's Jamboard. Yeah. So, what is your question, Noah?
How to do part 4?
How to do part 4. So let me copy your working. So you have dy dx, you have that thing, and then you have that thing, and then suddenly you have connected rate of changes like at part 3, right? Suddenly, right? Then and part 4, you have something weird, right? So variable c, right? Sure that one, no, right? So the moment that he say increasing at twice the rate, this is again a very big hint that we are talking about connected rate of changes. Do you see that first?
Yeah.
All right. So that means, again, the first step is to identify the two rate of changes, right? So we want dz dt and dy dt, right?
Mhm.
Dy dt you have already. Do you have dz dt?
No.
Can you find dz dt? I believe you can, but can you?
Oh.
Right. Then we progress from there. First thing first, you go and find dz dt. If it is possible, yeah. If not, then again, of course, there's also the connection. There's also the connection. What's the connection, by the way? Noah, what's the connector? So the two rates and the one
Dz
connect.
dy.
Yes, dz dy. So you also have to find dz dy. Again, I can tell you it's definitely doable, but can you do it? Right? A bit confusing, I know, but if you know, please do. If
How
not,
do I find Z?
all right. So dz dy is actually, I believe, easier than dz dt. Now, let me explain why. Usually, you will do dy dx, for example, right? Or dy dt, correct? You will expect this one to be from y as a function of x something something, right? And this one is from y as a function of t something something. Make sense? Simple, right? Now, dz dy, that means you were just looking at the dz and the dy, then you will expect it to come from z, which is a function of y something something something, correct? If that makes sense.
Yeah.
You already have it. You already have it in the form of z equals to y squared. Look, it's z and this is y, nothing else. So dz dy is extremely simple. It is 2y in this situation. Do you understand why that is?
But it's why this one up here.
Y is, yeah, but if you change that to this, with it, you change y into x, then doing dz dy is very difficult. But if you do dz dy with this only, then this is fine. After you do becoming 2y, then you may want to change it to that guy because you need the x to become equal to 3. That's the only reason why you want to change it. But later, not at the start, if you understand.
Okay.
Okay, that's dz dy. Now see whether you can find dz dt or not.
Okay.
If you cannot, that means you're supposed to know this and that. Then you know this immediately. So you're not supposed to find this. If you can find this and find this, you don't have to find this. This is done already. If that makes sense. Think about it for a while. Aryan, any questions so far? Aryan, any questions so far? Aryan, can you hear me? Aryan, can you hear me? Aryan, can you hear me, Aryan?
Hello?
Aryan, yes, can you hear me?
Yeah.
All right, so this is to let you know I was calling you for 3 times and then you respond. I think the audio problem. Okay, right. Okay, any problem so far?
No.
All right, understand. Michael, are you doing anything? Because I cannot follow your work.
Yeah, so I have like this half left over.
All right. Now, why is that not a problem? Not a problem at all. I can guarantee you that is not a problem, and you're also not doing anything wrong currently. You're
I
on the right track. Why is that?
I don't know if this is part of C.
Constant is a number, right?
Yeah.
So half can be absorbed into the constant without much effect lah.
So I can just get rid of half.
Not get it, absorb. So it's like this is constant 1, it becomes constant 2 lo, and in the sense, who cares about what's constant 2 is? It's half plus constant 1, whatever lo.
Oh, okay.
Not
Yeah.
get rid, just absorb, just absorb, right? So
Okay.
this can happen. This can happen.
Yeah.
The reverse can happen also, if you know what I mean. You can also draw any kind of number from the constant, right? You can also do that. Okay, so that's the identities. Like expect to use identities heavily in integration of trigonometry. Expect that. Expect that.
Okay. Yeah. Then I also have this question right here.
Which question?
Question 5, part 2.
Okay, I'm gonna look at question 5,
Oh,
part 2.
wait. Oh wait, no, wait. This is still 16.2.
Okay.
It's
Let me copy it.
question. Wait. Question 5, part 2.
Okay, wait. Okay, I'm gonna copy. Right. So by the way, Michael, I believe you're using 4G. Yes.
Yeah.
Excellent clarity. Yeah, excellent clarity. You don't zoom in. I can still see. Right. So a bit blurry, but okay. Right. So what is your question in this 5 part 2? So because you should have found the dy dx. Again, show me the dy dx.
X plus 2x ln x.
All right. Okay. So this is a slightly different flavor of integration. Again, if you integrate the two directly, you cannot. What's the problem?
If I integrate the 2.
Yeah, the part 2 directly without part 1. You have a problem if you do that. What is the problem?
Ln.
No, not a lot. The times. Well, I suppose you also
Oh.
cannot integrate the ln. That's also another problem. You have two problems. The times and the ln itself. Like, I don't know what's the integration of ln x. Okay, big problem, right? So this is the flavor of integration where you must use the part 1. You must. There is no other way. If not, it's impossible. So you have these two flavor in a holiday tuition. The one before is that you must make it possible, and this one, they give you the hint. So now the question is, how do I use part 1? How do I use part 1? Now,
I'm like sort of know how to use it, but then like
how?
it's having problems. I mean, I already wrote 2 lines, but then
All right.
the first one, it makes sense, and then the second one, I kind of don't know what to do when I get rid of the x here.
Right.
What
Okay. So what you're doing makes a lot of sense because you're integrating this guy, and then let me see. Then it becomes this. So I totally agree with your first line. I'm going to ignore C for a while, okay? Just so that it is not confusing. It's not wrong for you to write it down, but it's just I'm just going to write it down for visual clarity for now. Now, what you want is very simple. It's very simple. Please notice that integrating this is never possible in the first place, correct?
Yeah.
However, this is what we want. So that's actually good news. Now, what you should have done is that, okay, I'm going to leave this with a derivation of x dx equals to x squared ln x. This one can accept, yeah?
X dx equals
this
to
becomes
x.
that. I'm just splitting this to that. That's all I'm doing, right?
Yeah.
Right, and the right-hand side is still this one. Doesn't matter, right?
Yeah.
I'm giving you a lot of hints. I'm giving you a lot of hints.
Although just like integrate x.
You can. Yeah, you can, right?
X squared over 2.
Half x squared, right? Again, there'll be a c somewhere, whatever. So like this is already very close to the answer, don't you think? Super close.
Yeah.
Like, remember what you want is this. So can you continue?
Yeah. So.
All right, give it a try. Let me see. Noah, any problems so far?
No, almost done.
All right. Aryan, any problems so far? Aryan, any problems so far?
No.
All right. Okay. 5 more minutes, guys. Let's use it well. Yeah. And I'll see you tomorrow. Yeah, the over 2 seems fine, and you absorb the over 2 into the C also, which is excellent and great, Michael. Right. Any other problems so far, Michael?
I'm looking at question 7 right now.
Give it a try. Still give it a try. The trick must be, similar. Like it's not too tricky when you know the trend. Yeah. Noah, any problems so far? Oh, yeah, you did quite well, isn't it, Noah? So you decided that you are to find dz dt from the other two, basically, right? And you basically did that because you found that dy dz is equals to 2. That's basically what you found, isn't it? Correct, yeah? Anyway, you found it. So good job. This is just a slightly new form of connected rate of change. I hope you take it as something possible to happen in exam, right? Something possible to happen.
Okay.
Yeah. If it is not confusing, very good for you. If it is confusing, let me help you. Yeah. Any other question, Noah? Right. Okay. Today not so bad, Noah. So I'm still happy that you're doing all this. We have 3 minutes left. Aryan, any questions so far?
No.
All right. Okay. So Noah, if tomorrow there is no homework, right? Then we'll do mid-year preparation. Now let me ask you, the question that you did just now, is it homework? Is it you're preparing yourself?
Preparing because I don't have homework.
Your preparation itself is already good selection. I like the question. So if you have this kind of question, I tend to not give you questions of my own. If you're running out of challenging question, it's time for you to ask from me. Okay, understand it? So if I'm giving you question, it's not very different from what you're doing right now, is what I'm trying to say. So good for you. Right. Having said that, no, never mind. So good job. Right, so 2 minutes left, yeah? Okay, final question. Any problem so far, Aryan?
Yeah.
Any problem so far, Aryan?
No.
All right. Okay. Feel free to stop for today, and I'll see you tomorrow. Yeah. So Noah, any more problems?
No.
All right. Feel free to stop today, and I will see you tomorrow.
Okay, my God.
All right. Michael, how are things so far?
I think I'm good so far.
All right. Cool. I'm seeing that you're starting to get used to the problem. Good. Any final question then, Michael?
Yeah, question 9.
Question 9. Let me see question 9. Yeah. Like it, quite clear, right? Finally. Putting it in the Jamboard. Again, show me your working. Show me your working in question 9. Tell me what's the problem.
I have no idea what they want me to do when they say express that in the form of P plus Q over 3x.
Oh. Okay. Let me jog your memory. Yeah. So that's basically, never mind. That's long division. If that makes sense.
That's long division.
Yeah.
Oh.
Does it make sense? Can you do something with that hint?
Okay. Yeah.
Let me see.
I
Let me
guess.
see. Let me see your long division. Let me see your long. It's a very quick long division. Let me just see it. Then at least you can continue from there. Like super quick long division, super quick. Okay, I cannot see your long division, but I mean, if you're done, can show me. Okay, looks good. All right, yeah. Okay, that's one. Yeah. Okay, one. Then what will happen here? Okay, nice. Then yeah. What do we have here? Right. This is the end of your long division. It's not very long. Time to write. Time to write your result. Yeah. Totally. Yeah, actually, no. The way you write down is wrong, and it doesn't make sense at all. Don't erase things, because your long division is correct. Please. Let me jog your memory on long division. Look. By doing this, 30 divided by 7. Tell me what's 30 divided by 7? What would you write? What would you write?
3 at the top.
4, not 3.
Yeah, 4. Yeah.
And then
28.
And this 28 and then 2. And look at what I'm writing here. This is 30 over 7, isn't it? Right?
Yeah.
It becomes what?
4.
4 and then?
Plus 2.
Plus 2 over 7. Right? Also written as 4 2 over 7. But the point is there is a plus here. I'm giving you a lot of hints on your mistake.
Okay.
You understand your mistake based on this simple mixed fraction. Right. Remember this simple mixed fraction in exam so that you don't get mixed up. Understand?
Yeah.
Now,
I think
so
for the rest I should be good. Yeah.
Right. Please give it a try, and I hope you will later find out why they ask you to do long division, because they don't do this every time in exam. Sometimes they just whack you with what they give you, and then you're supposed to figure out, hey, I'm supposed to do long division. There's a clear benefit of the long division. I would wonder whether you know what it is, right? For the integration, right? So that's a food for thought. I will see you tomorrow.
Oh, yeah.
All right. Bye.
Bye.